Okay, question 5. See, discuss a question on the work energy theorem for this November 2017 paper. In the description box, as usual, guys, there will be links for other recordings engwayenzile for this question paper. If angiyenzanga, well, yes, but check out the description box for other links for this question paper. Before ngicala, I also have an announcement to make. Yes. The virtual master classes, it's another channel. It's my channel yami lena, where I do ama tutorials or ama lessons. On this channel angiphendula ama question paper. I'm just discussing ama lessons. So I would appreciate it if you subscribe to this channel as well. Ngingajabula kakhulu. So I cover everything from grade 10 to grade 12, both mathematics and physical sciences. In the description box, kune link for this channel as well. Check it out now. So lana ke basiphe a 2-body system, 4 kg, 6 kg block. Both blocks are being connected by a light inextensible string passing over a light frictionless pulley. So this is the string and this is the pulley. Okay, it's obvious, but I'm just pointing it out. Now bese siyabona ukuthi the 6 kg block move a vertical distance of 1.6 meters, right? Iyasikhomba la isuka la phelela la, which is a distance of 1.6, and then bese bathi initially the blocks are held at rest. This is important for this question. Keep it in mind. Bear that in mind. Now, 5.1, state the work energy theorem in words. So, net work done is equal to the change in kinetic energy. Net work done is equal to the change in kinetic energy. So, basically, the formula itself defines the work energy theorem. So the net work done on an object is equal to the change in the object's kinetic energy. You shouldn't lose marks afana nalawo. Definitions, stating laws, grab those marks. Make sure ukuthi uyawathola. Bese babuya bathi when the blocks are released, the 6 kg block falls through a vertical distance of 1.6. Okay. Before I go 5.2, I have this question or something ngifuna ukuthi unikeze some thought. If a 6 kg block will move a vertical distance of 1.6, right? 6 kg block, that's the distance being traveled by 6 kg. And then what's going to happen to 4 kg block as a 6 kg mover? Obviously, 4 kg block is move, but by what distance? By what distance? That's the question, or that's something ngifuna ukuthi unikeze some thought. Obviously, it's going to be 1.6. If umnganakho now you are being tied together by a string, then when you run forward, let's say mhlambe uzibophelele phambili wena, then you start moving forward or running forward by a distance of 2 meters. Umngane wakho move distance engakanani? Yes, 2 meters as well. So it makes sense nala ukuthi sithi 4 kg uzomove a distance of 1.6 meters as the 6 kg block. That's the second thing engifuna ukuthi keep it in mind. 2, second thing, and then this is the first thing, right? Of course, balulekile lo. Now 5.2, size la ku 5.2. Draw a label free body diagram for the 6 kg block for 2 marks. So the 2 kg block, we experience a tension force upward and a gravitational force downward. So it's 1 mark, 2 mark, right? It's 1 mark and 2 marks. So that's the free body diagram for the 6 kg block. And then go 5.3, but hey, calculate the work done by the gravitational force on the 6 kg block. So 6 kg block, calculate the work done by a gravitational force. So we know that work done by a gravitational force, or work done, is always calculated as force times delta x times it's cos theta, and then the force under influence, or the force of gravity, is calculated as mass times gravitational acceleration. So then we substitute here, manje. We substitute. And then m it's 6, and then 9,8, and then 1,6 with delta x is the distance traveled, 1,6, and then with theta, give that some thought. With theta la uzoba equal to 0. Ulo theta uzoba equal to 0 degrees. The direction of motion for the 6 kg block, the direction of motion is downward, and then the gravitational force is always acting downwards. It's also acting downwards, so the angle between parallel lines is 0 degrees. That's why it's 0 degrees. That's why it is 0 degrees. So therefore 6 times 9,8 times 1,6 times cos 0 degrees, answer is 94,08 joules downward. Ngiyadlala. I-energy is a scalar quantity, so ayina direction ke. 5.4. The coefficient of kinetic friction between the 4 kg block and the horizontal surface is 0.4. Ignore the effects of air resistance. 5.4. Question yamabhoza ke le. Bathi use energy principles to calculate the speed of the 6 kg block when it falls through 1.6 meters while still attached to the 4 kg block. Asibuyele back to the scenario, or the example enginikezile, between wena nomngane wakho being tied to a rope. Wena uma ngabe ugijima ngo 2 meters per second, umngane wakho ugijima ngespeed esingakanani? Of course, ngo 2 meters per second. Now travel a distance of 3. Now umngane wakho travel a distance of 3 meters, right? So the message engizama ukuyiconvey la ukuthi the 4 kg block, the 6 kg block, they are being connected by a string. So it means that they are one system. Nanga being accelerator by 1 or 4. No 6, now you accelerator by 1. If 4 will move by a distance of 2 meters per second, the same applies now to 6 kg block, 2 meters per second. Why am I bringing this up? Why am I bringing this up? It doesn't matter what to calculate a speed for which block. For 4 kg, 6 kg, yokusalayo yothola the speed for the whole system, right? Yothola the speed for the whole system. It applies go 4, ibuye apply nobani na go 6. So yeah, okay, laba to use energy principles, right? Energy principles. Now but use energy principles, you have the choice ukuthi ngathi it's up to you to sebenzisa which method of calculation, whether usebenzisa i-work energy theorem, net work done equal to change in kinetic energy, or you use non-conservative forces, change in potential energy plus the change in what's this, kinetic energy. So for this video I'll only do work energy theorem. I'll use the work energy theorem to do this calculation. I'll use the work energy theorem to do this calculation. So bheka-ke manje, net work done is equal to the change in kinetic energy, right? Change in kinetic energy. Okay, so you understand uthi yosebenzisa the change in kinetic energy. Work done is equal to the change in kinetic energy. But for which block? 4 or 6? Mina ngithi way 2. 4 kg and 6 kg. So consider the change in kinetic energy for the 6 kg block and the 4 kg block. Ngoba whatever 4 kg block ayenzani no 6 kg block wenzani uyayenza. So ngathini u4 kg no 6 kg they are in sync, are synchronized. So u4 no 6 same WhatsApp group, whatever yenza nalo uyayenza, right? So in other words, ichaza ukuthi uma so calculate the net work, we are going to consider the work done on the 6 kg and the 4 kg, right? And then whatever kinetic energy so you calculate, so consider for the 4 kg as well as the 6 kg. Yes, okay, let me do the calculation so that we understand guys. Now asiqale ngelokazi, asiqale net work done. Let's consider all the forces in this system. Maybe na into engayenza la, let me erase lana ngoba sekuhlangene. Okay, sekuclean ke manje. Let's start off our calculation by calculating net work done. So net work done is equal to net work done, it's the sum of all the forces, or actually it's the sum of all the work done on every block on the system. So asiqale ngokuthi work done by frictional force. Ubani experience frictional force la 4 kg block, right? So the frictional force is doing work on this entire system, plus work done by the gravitational force. Gravitational force is doing work on which block? The 6 kg block, which is something as calculated like 5.3, plus the work done by the normal force. The normal force is also doing a work on this block. Is it? Nah. But okay, let's just asipale, and then as well as the force, the gravitational force by the 4 kg block. So let me do this and do this, plus work done by the gravitational force of the block. These two are actually equal to 0, but uzoyibona manje in a moment. So this work net is equal to work done by the frictional force, it's mu k, right? Alright, ngilande step by step. It's force of friction times delta x times cos theta, plus the work done by the way the gravitational force is what? Is 94,08, plus work done by the normal force, it's 0. It is 0. Wonke ama perpendicular forces, they do 0 work. All the perpendicular forces, they do 0 work. Ngikhuluma ngama situations over a horizontal surface. All the perpendicular forces, they do what? They do they do 0 work. Also siyazi ukuthi work is equal to F times delta x times times theta equal to, let's say we have a force now of 3 times a distance of 1,8. I'm making an example, so I'm moving away from the question 5 just to demonstrate the work done by all our perpendicular forces is equal to 0 times what's the angle theta for these perpendicular forces. It's 90 degrees. Also the direction it's this way, but the force is acting upwardly and it's acting downward, so it means it's 90 degrees. And we know that cos 90 degrees now, cos 90 degrees is equal to 0 degrees. So yonke lento leyo bawubani u0, hence ngithi la it's equal to 0 degrees. There's no need to consider, but I was just showing ukuthi in fact these two are equal to 0. So therefore the frictional force is calculator njani? Yes, it's mu k times the normal force plus times cos theta plus 94,08 equal to mu k, the kinetic coefficient of kinetic friction is 0,4 times normal force. Also the normal force N for the 4 kg block is equal to mg, or the weight. So mass it's 9,8 times what's delta x for 4 kg block? It's 1,6. sakhumbula ngenza example ngomngane wakho nawe ngithi u6 nakamuva 1,6 yomuva 1,6 naye nomngane wakho wena na umuva 2 meters nomngane wakho umuva 2 meters. Cos theta, what's theta? It's 180 degrees. Direction, frictional force is always acting in the opposite direction, so it's 180 degrees plus 94,80. So as he calculated this one, so what notice tolanga is 0,4 times 4 times 9,8 times 1,6 times cos 180 close plus 94,08 is equal to 68,992. Okay, this is not our final answer, so ngingayithatha yonke, so 68,992 joules. So this is the work, the net work done. So shall I space lana ya erase la phezulu so that I can continue nale calculation lami. Okay, siyaqhubeka ke nalo, siza la sithi net work done is equal to change in kinetic energy. So this is equal to half m half m v final squared minus v initial squared, right? V initial squared plus lona it's for the 4 kg block. Ukhumbule kunama block ayi2 and the way 2 enzani ayamove, so it's a 2-body system, so we have to add the kinetic energies for both blocks. The change in kinetic energies for both blocks, so equal to, so therefore net work done over 68,992. so 68,992 is equal to 1/2 right, for the 4 kg block, open bracket, final velocity I don't know, ngifuna yona. The final velocity actually it's what, sifuna the speed of the 6 kg block when it falls through the height, so that's the final velocity. Initially we know they were held at rest, but they were held at rest, so it's 0 plus 1/2 6 okay plus 1/2 6 v final minus 0 okay, let me erase nala ngaphansi, then siqhubeka nayo 68,992 is equal to, so a half times 4 is 2 v squared, vf squared minus 0, it's vf squared, and then lana it's going to be 3. Then like about half times 6 is 3 times vf squared, it's plus 3vf squared. So 68,992 equal to, ungakwati yaphela manje, ungakwati, sesiqedile na, bhek kwamele ujabule nasowufika la, ngoba it's just iloka imaths nje kuphela le. Divided by 5, answer yethu nayi ke, divided by 5 or answer yethu le, ngoba kusokomele ngifake square root 7984 equal to vf squared, squaring both sides, square both sides, so the square root of our answer is equal to 3,71 meters per second, equal to vf. This is our final answer here. 5.4 concludes our video here. So I hope we enjoy it. I hope you learned something. I hope uthola some value out of this video yanamuhla. So yeah, ungakhohlwa ukulike, ungakhohlwa ukushare, ungakhohlwa ukusubscribe, ungakhohlwa ukusubscribe on the other channel as well. Ungakhohlwa nokulike nangabe uyi-enjoy i-content yami. So for now guys, asibonane on the next one. Thanks for watching and bye bye.